Hello everyone, my name is Dr. N L Aravindha from AC Department, Mallarati Engineering College for Women. So now I am going to deal with the subject probability theory and stochastic processes. So what is probability? So every day we'll speak some random concepts like we'll get some concepts like whether we will get rain or we'll get heavy heat, like that. So we will guess like that. So whatever concept like randomness is present, so that randomness concept will be represented by this probability concept. So this probability is nothing but, first we need to talk about the experiment. So what is experiment? So experiment is nothing but performing some task. So whenever you are discussing about any task, so it will have some outcomes or outputs. So those outcomes are nothing but, if you take one example like tossing a coin, right? So in that coin experiment or flipping a or tossing a coin experiment, you have two outcomes like getting head or getting tail, right? So I'll ask a question like, what is the chances to get a tail when a coin is tossed? So we can relate this concept to the probability, right? So guessing concept is nothing but probability concept. So we need to consider the randomness in nature, right? So experiment is nothing but performing task, right? So here we have the random experiment is nothing but performing any task without guessing or without considering precise output, right? If you consider tossing a coin or flipping a toss, or even if you consider playing cards or cards, like that, okay? So they are nothing but random experiments. So if you consider experiment, right, I already told that the outcomes. So whenever you are taking an experiment or a task, what are all the possibilities of outcomes? If you represent those all outcomes as I said, that is called as sample space. So sample space is nothing but set of all the possibilities of an experiment, right? Next comes to this probability definition. So we have multiple definitions for probability. If you consider relative frequency as a parameter, the probability definition is nothing but n of a by n of s. So before telling about all these formulas, so I will tell A is an event, so which comes from an experiment, right? So A is an event, right? So capital S is the sample space, and that sample space is nothing but set of all the possibilities. So to represent number of number of outcomes from the sample space, we will represent as n of s, and n of a is nothing but number of possibilities for getting event A. So from this we can say that the probability of a particular element A, P of A, is nothing but n of A by n of S. That means number of favorable conditions for getting event A by number of all the possibilities, that is nothing but number of elements in the sample space. So that is the formula for probability of event A. So comes under sample space. So I already told that it is a set of all the possibilities of an experiment. So we'll discuss some examples. So if you take a coin experiment, so for coin experiment, the sample space is denoted as heads and tails, and for this n of a is getting either head or tail. So here n of s is 2 because we may get head or tail. And if you take 2 coins, so there is a chance of 4 outcomes like head head, head tail, tail head and tail tail. So similarly, if you take 3 coins, so we may have a possibility to get 8 possibilities as sample space. So in this way we can generate a formula if you take n number of coins. So for 1 coin we are getting 2, 2 coins we are getting 4, 3 we are getting 8. Similarly, if you take n coins, the n of s is given by 2 power n. And if you take another experiment like rolling a die. So in the die we have 6 faces. So here sample space is given by 1, 2, 3, 4, 5, 6 and n of s is nothing but 6 elements. So n of s is 6. Suppose if you take 2 dice. So for 2 dice the n of s is combination of 2 elements like 1, 1, 1, 2 up to 1, 6 and 2, 1, 2, 2, 2, 3. Similarly up to we'll get 6, 6. So totally we'll have 6 power 2 which is nothing but 36 elements for 2 dice. Similarly, if you take n dice, for n dice, n of s is 6 power n. So in this way we will calculate sample spaces. So in the sample spaces we have 2 types, continuous sample space and discrete sample space. In discrete sample space we have countable number of elements and they are finite. And if you take continuous sample space, in this we have infinite number of elements and we can't say particular number. So I'll give one small example. Suppose for continuous sample space s is equal to, I will represent 1 less than or equal to s less than or equal to 6. So what it represents, 1 to 6 means we'll simply say that 1, 2, 3, 4, 5, 6. So it comes under only discrete sample space. But in 1 to 6 range we have 1.1, 1.2 like that. So in this we have infinite number of elements. So this is the difference between discrete sample space and continuous sample space. Thank you.